Lesson 2. Periodic classification of elements. Elements and their classification. Dobereiner's triads. Newland's law of octaves. Mendeleev's periodic table. Modern periodic table. Can you recall? 1. What are the types of matter? 2. What are the types of elements? 3. What are the smallest particles of matter called? 4. What is the difference between the molecules of elements and compounds? Classification of elements. We have learnt in the previous standards that all the atoms of an element are of only one type. Today, 118 elements are known to the scientific world. However, around year 1800 only about 30 elements were known. More number of elements were discovered in the course of time. More and more information about the properties of these elements was gathered. To ease the study of such a large number of elements, scientists started studying the pattern, if any, in the vast information about them. You know that in the initial classification, elements were classified into the groups of metals and non-metals. Later on, another class of elements called metalloids was noticed. As the knowledge about elements and their properties went on increasing, different scientists started trying out different methods of classification. Dobereiner's triads. In the year 1817, a German scientist, Dobereiner, suggested that properties of elements are related to their atomic masses. He made groups of 3 elements each, having similar chemical properties, and called them triads. He arranged the 3 elements in a triad in an increasing order of atomic mass and showed that the atomic mass of the middle element was approximately equal to the mean of the atomic masses of the other 2 elements. However, all the known elements could not be classified into the Dobereiner's triad. Serial number, triad, element 1, actual atomic mass in bracket A, element 2, mean is equal to A plus C upon 2, actual atomic mass, element 3, actual atomic mass in bracket C. 1. Li-Na-K. Lithium Li 6.9. Sodium 6.9 plus 39.1 upon 2 is equal to 23.0. Na 23.0. Potassium K 39.1. 2. CaSrBa. Calcium Ca 40.1. Strontium 40.1 plus 137.3 upon 2 is equal to 88.7. Sr 87.6. Barium Ba 137.3. 3. Cl-Bri. Chlorine Cl 35.5. Bromine 35.5 plus 126.9 upon 2 is equal to 81.2. Br 79.9. Iodine I 126.9. Mendeleev's periodic table. The Russian scientist Dmitry Mendeleev developed the periodic table of elements during the period of 1869 to 1872 AD. Mendeleev's periodic table is the most important step in the classification of elements. Mendeleev considered the fundamental property of elements, namely the atomic mass, as standard and arranged 63 elements known at that time in an increasing order of their atomic masses. Then he transformed this into the periodic table of elements in accordance with the physical and chemical properties of these elements. Mendeleev organized the periodic table on the basis of the chemical and physical properties of the elements. These were the molecular formulae of hydrates and oxides of the elements, melting points, boiling points, and densities of the elements and their hydride and oxides. Mendeleev found that the elements with similar physical and chemical properties repeat after a definite interval. On the basis of this finding, Mendeleev started the following periodic law. Properties of elements are periodic function of their atomic masses. The vertical columns in the Mendeleev's periodic table are called groups, while the horizontal rows are called periods. Introduction to Scientist. Dmitry Mendeleev, 1834 to 1907, was a professor in St. Petersburg's University. He made separate card for every known element showing its atomic mass. He arranged the cards in accordance with the atomic masses and properties of the elements, which resulted in the invention of periodic table of elements. Demerits of Mendeleev's periodic table. 1. The whole number atomic mass of the element cobalt, Co, and nickel, Ni, is the same. Therefore, there was an ambiguity regarding their sequence in Mendeleev's periodic table. 2. Isotopes were discovered long time after Mendeleev put forth the periodic table. As isotopes have the same chemical properties but different atomic masses, a challenge was posed in placing them in Mendeleev's periodic table. 3. When elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. It was not possible, therefore, to predict how many elements could be discovered between two heavy elements. 4. Position of hydrogen. Hydrogen shows similarity with halogens, group 7. For example, the molecular formula of hydrogen is H2, while the molecular formula of fluorine and chlorine are F2 and Cl2 respectively. In the same way, there is a similarity in the chemical properties of hydrogen and alkali metal, group 1. There is a similarity in the molecular formulae of the compound of hydrogen alkali metal, Na, K, etc., formed with chlorine and oxygen. On considering the above properties, it can be decided whether the correct position of hydrogen is in the group of alkali metals, group 1, or in the group of halogens, group 7. Modern periodic law. The scientific world did not know anything about the interior of the atom when Mendeleev put forth the periodic table. After the discovery of electron, scientists started exploring the relation between the electron number of an atom and the atomic number. The atomic number in Mendeleev's periodic table only indicated the serial number of the element. In 1913 AD, the English scientist Henry Moseley demonstrated, with the help of the experiments done using X-ray tube, that the atomic number Z of an element corresponds to the positive charge on the nucleus, or the number of the protons in the nucleus of the atom of that element. This revealed that atomic number is a more fundamental property of an element than its atomic mass. Accordingly, the statement of the modern periodic law was stated as follows: properties of elements are a periodic function of their atomic numbers. Modern periodic table, long form of the periodic table. The classification of elements resulting from an arrangement of the elements in an increasing order of their atomic number is the modern periodic table. The properties of elements can be predicted more accurately with the help of the modern periodic table formed on the basis of atomic numbers. The modern periodic table is also called the long form of the periodic table. In the modern periodic table, the elements are arranged in accordance with their atomic number. As a result, most of the drawbacks of Mendeleev's periodic table appear to be removed. However, the ambiguity about the position of hydrogen is not removed even in the modern periodic table. We have seen in the previous standard that the electronic configuration of an atom, the way in which the electrons are distributed in the shell around the nucleus, is determined by the total number of electrons in it, and the total number of electrons in an atom is same as the atomic number. The relation between the atomic number of an element and its electronic configuration is clearly seen in the modern periodic table. Use your brain power. Position of the elements in the periodic elements. 1. How is the problem regarding the position of cobalt 59Co and nickel 59Ni in Mendeleev's periodic table resolved in modern periodic table? 2. How did the position of 35Cl17 and 37Cl17 get fixed in the modern periodic table? 3. Can there be an element with atomic mass 53 or 54 in between the two elements chromium 52Cr24 and magnesium 55Mn25? 4. What do you think? Should hydrogen be placed in the group 17 of halogens or group 1 of alkali metals in the modern periodic table? Structure of the modern periodic table. The modern periodic table contains 7 horizontal rows called the periods 1 to 7. Similarly, the 18 vertical columns in this table are the group 1 to 18. The arrangements of the periods and groups result into formation of boxes. Atomic numbers are serially indicated in the upper part of these boxes. Each box corresponds to the place for an element. Apart from these 7 rows, 2 rows are shown separately at the bottom of the periodic table. These are called lanthanide series and actinide series respectively. There are 118 boxes in the periodic table including the 2 series. It means that there are 118 places of elements in the modern periodic table. Very recently, formation of a few elements was established experimentally, and thereby the modern periodic table is now completely filled. All the 118 elements are now discovered. The entire periodic table is divided into 4 blocks, namely S block, P block, D block and F block. The S block contains the group 1 and 2. The groups 13 to 18 constitute the P block. The groups 3 to 12 constitute the D block, while the lanthanide and actinide series at the bottom form the F block. The D block elements are called transition elements. A zigzag line can be drawn in the P block of the periodic table. The 3 traditional types of elements can be clearly shown in the modern periodic table with the help of this zigzag line. The metalloid elements lie along the border of this zigzag line. All the metals lie on the left side of the zigzag line, while all the non-metals lie on the right side. Modern periodic table and electronic configuration of elements. Within a period, the neighboring elements differ slightly in their properties, while distant elements differ widely in their properties. Elements in the same group show similarity and gradation in their properties. These characteristics of groups and periods in the modern periodic table are because of the electronic configuration of the elements. It is the electronic configuration of an element which decides the group and the period in which it is to be placed. Characteristics of groups and periods. The characteristics of the groups and periods in the periodic table are understood by comparison of the properties of the elements. Various properties of all the elements in a group show similarity and gradation. However, the properties of elements change slowly while going from one end to the other, for example, from left to right in a particular period. Groups and electronic configuration. Can you tell? 1. Go through the periodic table and write the names one below the other of the elements of group 1. 2. Write the electronic configuration of the first 4 elements in this group. 3. Which similarity do you find in their configuration? 4. How many valence electrons are there in each of these elements? You will find that the number of valence electrons in all these elements from the group 1, that is, the family of alkali metal, is the same. Similarly, if you look at the elements from any other group, you will find the number of their valence electrons to be the same. For example, the element beryllium Be, magnesium Mg and calcium Ca belong to the group 2, that is, the family of alkaline earth metals. There are 2 electrons in their outermost shell. Similarly, there are 7 electrons in the outermost shell of the elements such as fluorine F and chlorine Cl from the group 17, that is, the family of halogens. While going from top to bottom within any group, 1 electronic shell gets added at a time. From this, we can say that the electronic configuration of the outermost shell is the characteristic of a particular group. However, as we go down a group, the number of shells goes on increasing.